Hello, friends. Thanks for tuning in. My name is James Craig Wilson, and I am enjoying my opportunity to have access to all of this. You, my friends out there. I have a lot of questions, and before I get started into all that, I would like to say thank you for being my friends. Again, feel very blessed to be able to ask these questions, to compare notes with you. My questions today have a lot to do with numbers. I was not all that great at math when I was a kid. I happened to have a teacher that really took interest in me and had other kids that were really good in math help me tutor. And I was very happy. I wanted to be smart like they were, so I tried very hard. The thing that I have a question about is how we get numbers. I've been told is the language of God, and I have also been told that numbers never lie. I find a lot of truth in that as I dig deep into the numbers, and some of this is rather biblical. I wondered why there are certain numbers that always crop up in the Bible. There's like 12 disciples, there's 12 loaves and 12 fishes. Um, well, going even bit beyond the Bible, there are 12 constellations. There were 12, what we said, 12 disciples already. There's 12 months in the year, 12 zodiac signs. There's 12 eggs in a dozen. Anyway, 12 seems to come up rather frequently. And in zodiac signs, right, we've got all that. I'm sure you could probably think of a lot of, there's other 12s that I've forgotten. I was researching this. Where did 12, why 12? And one possible answer to that is ancient Samaria popped up maybe 12,000 years ago, something like that, maybe. And all of a sudden, the written word and math and sciences and all that stuff just kind of appeared all of the sudden about 12,000 years ago. That's a story. And as I read, part of the story of why 12 came up was because you have 12 digits. No, you have four, right? There's four. Okay. See how good I am at math? And what it was suggested was that your four digits have one, two, three segments, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 segments. I think those are called carpals, something like that. Metacarpals, carpals, I don't know, carpal tunnel, something like that. Anyway, but these little segments equal 12. So that would give you the 12 right there. And if you imagine an early civilization counting, they might have gone 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How cool is it that you could count to 12 on four fingers? And that's where a dozen came from. You got 3 times 4 equals 12. Pretty cool. Now, where did 60, like 60 seconds, 60 minutes, 60 degrees, then 60 and 90 and 180 and all those things like that, where did all that come from? Well, add this. Look at this. So this little guy gives you 5. Okay? So 5 times 12 equals 60. I mean, this may be a bit of a stretch, but so you could go, imagine counting like that, and now you've got 12, but now you want to go 5 dozen, and you've got 60 total. And I'm doing this all in one hand. Now I'm going to do binary, and forgive me if one of these binary numbers flips you off. but it's true. This is zero. Zero is a concept, numerical concept that didn't come along, but the Sumerians kind of had an idea that there was a null, a zero. Okay, this is the center point. If you imagine infinity, that's an 8 kind of a thing laying on its side. Infinity, there's no beginning, there's no end, but in that center, where the, if you can imagine, okay, if that's infinity, this right here is the 0 point, the null point, right? Okay, so that's 0. In binary, I've got four bits, okay? This is 0, which is as much 1. We'll have to go back to that concept. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I can count to 16, or did I say 15? On one hand. So I got this is 15 in binary, and it's 12 in Sumerian, and it's 60 in Sumerian. And actually, I don't even know what if binary, so that adds, go figure. So that in today's world, we don't count like that. I come back to my questions. So we've got 12 and 60. We've got binary. We've got the number 9. And what's really interesting to me is the number 9 is ubiquitous. So I've got this Sumerian, right? That's 4. And this is 5. 4 plus 5. Now that's called root math. So 4, 45. Okay. There's a lot of ways to look at the numbers, right? 45. So 4 plus 5 equals, did I get that? 9. So that's 4 plus 5 equals 9, right? Now, 4 times 4 equals what? 16. Yeah, that's 7 in root math. So 7, maybe that's why that's a magic number. But then 12 in Sumerian, 12 times 12 equals 144. So in root math, so 144, 144. So 1 plus 4 plus 4 equals 9. Dig that. I, again, want to invite any of my friends out there that understand doubling, root math, Tesla, vortex math, any of that sort of stuff, jump in. Also, sacred geometry. If I told you that the number of degrees in a circle is 360, would you believe me? Well, don't believe me. It's Pythagorean stuff, right? But 3 plus 6 plus 0 equals what? 9? That is correct. I'm going to totally look at my notes here. The next geometric shape, the one that has 3 sides, is a triangle, right? If you add the degrees of an equilateral triangle, you're going to get 180 degrees total, the inner degrees of a triangle. And 1 plus 8 plus 0 equals what? 9? Well, right. Square. Let's go to a square. Certainly, this can't hold true for all these geometric shapes, but a square is a sum of 90 plus 90 plus 90 plus 90 equals what? 360. Same as a circle. Is it not interesting to you that a circle and a square have the same number of degrees? A pentagon. No way. Pentagon's what? 5-sided shape, right? A pentagon. I don't know how to make that, but it's something like that. Pentagon has a sum of 540 degrees, the inner angles of the pentagon. So 5 plus 4 plus 0 equals 9. Go figure. Well, certainly we jump up to the next, a 6-sided. So pentagon's 5, hexagon is 6. So a 6-sided shape would be a hexagon, and the sum of its angles are 1080, 1080. So 1 plus 0 plus 8 plus 0 equals 9. Go figure. Okay, let's go crazy. Septagon, seven-sided figure. That's before you get to a stop sign. I'm not going to stop until I get to the stop sign. Septagon. Add up the degrees of the inner angles of a septagon, and you will hopefully find it's 900 degrees. 9 plus 0 plus 0 equals, right, 9. Finally, I'm going to stop here for now. Octagon. We're at 1080. 1080. So 1 plus 0 plus 8 plus 0 equals 9. I'm going to take a jump into something the Pythagorean dude was into. Pythagoras was into music and spirituality, geometry, and much, much more. He saw things in a very amazing way. And he also was one of the first people that thought about how to tune an instrument. String theory, not the way that we in the modern era see string theory, but taking a string, a catgut or whatever, stretching it across and going bing, like a harp, like David played a bing. Pythagoras would have been the guy that probably bing, learned how to tune it. So it'd go bing, 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 bing. A string vibrates at a certain number of times per second. In today's modern music, an A is 440. I've got a tuning fork over there on my piano. You can bang it. And that thing's vibrating at 440 times a second. That's pretty quick. It's moving so fast that it looks like it's not even moving. We'll come back to that in physics later, kids. Anyway, so Pythagoras talked about this, that the number of degrees in a circle being 360, how he knew this without modern scientific instruments, I don't know. But 360 vibrations per second is what we would now call approximately an F sharp. And the triangle, which is the next geometric shape, vibrates, if you tune that, actually the vibration of a triangle at 180 cycles per second happens to be an F sharp 1 octave below. That would be a harmonic, it's one below that. So an octave below. Now you get back to the square and you're back to 360. So a circle and a square have the same number of vibrations per second. So they are in harmonic. They ring the same. The square and the circle, you can imagine that in geometry, the square and the circle vibrate the same. If you can imagine sacred geometry, the music of the spheres, if you will. Now we're going to jump up to the pentagon. Check this out. The pentagon vibrates at 540 cycles. Now, for those of you who know music, we're talking the key F sharp and then an octave below F sharp. Now, we've got a note in between those two. It's 540. That is the octave fifth. It's a C sharp. Okay. That is very interesting. Now we go to the, what do we got? Pentagon. Then we got the hexagon, six-sided. Six-side angles, equal angles. Even if you bend it, it doesn't matter. Same with the triangle. You can bend those. It still adds up to the same. No matter how you got a triangle, the degrees always, that's Pythagorean theorem. And for those kids that, hey, correct me if I'm wrong. But anyway, so we're up to the hexagon and I got 1080, 1080. So 1080. That is the octave fifth. So that is twice 540, you might notice. So now um, I've got another C sharp right there, don't I? Correct me if I'm wrong. No, 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 no. That's an F sharp. So 1080 is okay, that's an F sharp. And then the septagon and the octagon and the hexagon is strange that they both can be 1080s. So these 540 and the 900, there's a whole lot that I got to do. This is why I'm asking you guys, jump in with me. I've gone a little bit further outside of what I really understand, but these are questions. And I know that even when we get into the three-dimensional geometry, like we're getting into a tetrahedron, a cube, an octahedron, or an icosahedron, we're looking at 720, 2160, 1440, 3600. So we got an F sharp, a C sharp, an F sharp, an A sharp. That's the 900, and the 3600 are both the A sharps. So this is sacred geometry. We're looking at the flower of life patterns, these intersecting circles, all of this mathematical stuff. And for some reason, all of this builds a perfect third, triad. And all you add these things together, this root math, you get nines all the way. You do this, you get doubling, and you do root. Hey, is anybody out there as not so cuckoo as me? Hey, let's find out.